Well, thank you, everybody. Thanks for being here. I'm glad to share our story on TritonGPT. And below here, I've listed our team that have all participated in the project since we started about a year and a half or so ago. And I'm going to sort of jump right in with why we are doing it. The overall outline I'm going to talk about tonight is a little bit of kind of where we are in AI and from an economic and a sort of technology perspective. I'm going to talk about our strategy here at UC San Diego. And then I'm going to talk about how to think about knowledge inside our university or inside any organization, how that relates to AI. And I'm going to share some details about our AI platform, which is now a very strong agent management or agentic platform called TritonGPT. Perhaps the first thing to note are that while AI has been very important, it's been growing significantly, AI is getting smarter, but not as quickly as it used to. The models are reaching into what is called an efficient compute frontier. They aren't getting a whole lot better. In fact, in the last day or so here in the United States, and probably you've seen it too, there's more stories about the new reasoning models causing hallucinations. And these have implications. The transformer model has some limitations. I'll talk more about that. It's sort of governed our thinking about how we work with AI and why we use open source. And I think the implications here, while that's kind of a problem, you expect AI to get better and better, the solution to that problem, in other words, how to create AI that actually works for an organization, you have to work at smaller increments. You have to create agents. You have to tackle very specific processes. And so while that limitation might be troublesome, on the other hand, it opens up a whole bunch of opportunities for all sorts of startups and new ideas that can come forward. At the same time, our operational costs for AI are getting lower. These are token prices over the last couple of years, and we can see that all the models, their token prices have dropped significantly. While we are running our TritonGPT on-premise in NVIDIA clusters in our supercomputer center, our cost of tokens is still, 1/3 or so of the cost of tokens from OpenAI or from Google. I don't see these token prices coming down too much faster, partly because AI is very expensive for the cloud providers to run. At the same time, we're seeing this tremendous growth of data centers needed to support AI. And this is expected as prices for AI come down and AI gets more cost effective, demand can go up. There's some debate, though, on whether demand is really going to increase and how much it's going to increase. And it has to do with how successful AI is going to be inside organizations. So we'll be watching that over the next few years. But so far, demand is increasing pretty widely across many industries, including in education. With inside an organization or university, adopting AI might not lead to benefits right away. And this is a well-known, what they call solo paradox, or the productivity paradox, or the J-curve of productivity, in which you start to deploy an AI solution. It takes you time, it takes you money. You may not recoup that money right away. It might take you a year or two or three to actually make a significant impact on productivity or improvement. And that's well known. We've been watching these productivity paradoxes since the 1980s when it was first discussed. And so that's just a way of reminding my organization, yes, we do want to get productivity gains. We want to see improvements in teaching with AI, but you can't set your expectation it's going to happen within 6 months. It may take longer. Now, the flip side of this, I showed you charts done by industry analysts. I actually used an AI tool called Perplexity and used their deep research model a little while ago. And I gave it a simple prompt, and it fetched me the data that I just showed in 2 of the slides. And it took me about 6 minutes to actually about 4 or 5 minutes to do all the prompting. It was write that prompt out and then do some other prompts to kind of correct it. And it came back with a bunch of data that I then copied and pasted into Microsoft Excel, and I spent the next 20 minutes being an interior decorator, figuring out what colors I wanted to use on the line charts. This is exactly where AI can shine, in that it finds knowledge in the internet or in the language model or within your own data or in your own learning systems and brings it back. And I just did this in a few minutes. So clearly AI is, I used to be a consultant and would spend hours doing this type of analysis. Now I can do this analysis very quickly. Now AI is starting to dip into reasoning, and because of my background in human-computer interaction, I've had to accumulate a fair bit of knowledge about cognitive psychology, especially functional and neural anatomy of parts of the brain that participate in reasoning. And when the big AI companies talk about reasoning, it's really not reasoning as we know it in cognitive psychology. It's more like continuing to find ways of rephrasing the questions behind the scenes or structuring the questions behind the scenes in order to get a response out. So I still think AI is going to be deficient in many things for quite some time, and that's a bad thing because it opens the door to agents and using agents to get more performance out of AI. But I think 4 things are going to need to happen for AI to really support reasoning and become extremely intelligent sort of things. And the first one, probably not in the cards anytime soon, is the ability for the LLM to learn on the fly. Right now, these large language models take time and money to develop. So the large companies spend hundreds of millions of dollars to create the models. They are frozen. They do not learn. Now we've augmented them with internet search tools where the internet can learn, do things as things pop up in the internet, but by and large, the model doesn't learn. Secondly, there's a part of reasoning that's necessary, and that is what we call first order logic or crisp relational reasoning. These are foundational in human reasoning, and those are not quite there in the LLM. We are working on, and the industry is working on ways around that, using graph databases to encode predicate logic or relationships between certain things, like Mary hit the ball. That's a relationship between 3 things. That's called a triple. Graph databases are good at picking up some of that, and that can help with some of the reasoning, but it's still not a replacement for reasoning. I think a big skill we have to get in the AI are cognitive reflection skills. This is a critical part of human psychology where oftentimes before we give an answer, we stop, we think, we ask ourselves silently in our head, is it true? And then we formulate our answer. AI tries to do that, but it can't do a good enough job. So I think this notion of cognitive reflection has to be addressed forthwith within the AI models. There are things we do in our agent development behind the scenes to kind of get some of that in there. And then lastly, we won't see this for any time soon, but how can the AI conserve energy as it improves its skill? Some of that thinking is going into our AI platform, but it's nowhere near the way the human brain works. One of the ways we measure the difference between somebody who's an expert in a knowledge task from somebody who's a novice is if we measure the neural activity in the brain for the novice, their brain is extremely active. It lights up like a set of light bulbs. In the expert, the brain is not very active. So the expert conserves energy as part of skill acquisition. And that actually occurs inside the brain through how the neurons and the axons, the dendrites reshape and reform, and how the task inside the brain gets moved around in order to conserve energy. The current crop of AI does nothing like that sort. This is a long way of saying that the current AI has limits. And the only way out of those limits in the short term is agentic development and agent frameworks. I'm going to talk about our strategy here at UC San Diego. We're focusing on what we call vertical AI instead of horizontal AI. This is AI where we focus on our content and our data. and that data comes in two forms: websites, documents, data in our data warehouse. But another piece in our strategy is how to give everybody in the university access. So right now, our TritonGPT platform is open to all all faculty and all staff. So that's 38,000 people. And we don't charge their units. That's all covered internally in my unit. It's actually much lower cost than people would realize. We're still about a tenth or lower the cost of the pricing from OpenAI, from Google and Anthropic and others. We're about to open up access to all students here in another month, and that's going to be another 44,000 people in our system. So we're going to have just shy of 80,000 people, or just shy of 90,000 people in our TritonGPT platform, running very comfortably within our clusters in our supercomputer center. We are leveraging open source models to do this. Otherwise, the cost would get fairly exorbitant. And then also, given the way AI is going here, and things are popping up and new things are coming out all the time, we're still doing it in a way that we could use cloud platforms if we wish, and in some cases we do, but also that we can be flexible on even the open source models that we use. This picture just kind of shows that chart. You can think of horizontal AI as AI that anybody can use pretty much out of the box. So if you use Microsoft Copilot or you use OpenAI, you might pay the amount per month for it, and then you get access to it, and everybody can use it. And there's no real distinction for the institution or the company. In vertical AI, you're really going to be AI focused on your technology, or on your content, on your data, and on your processes. And so now it's kind of locked in the data in your organization. It's not necessarily available to others. We think that's where our work has to be inside our organization on this vertical AI component. This is a very busy slide. I'm not going to spend too much time talking about it. I actually wrote about this with this slide in a LinkedIn post on knowledge metabolism. But we're starting to think of how knowledge flows inside our university between faculty and students, between administrators and the system, and how the AI actually works to generate a response. And so we think of all these bits of content in our websites, in our PDF documents, in our Word documents, our Office documents, as little sentences or knowledge fragments. And we accumulate a lot of them inside our metadata within the AI platform. In some cases, we elicit knowledge from our experts. We talk to them and we write up things. We have policies and procedures document, which contain a lot of that expertise in it. But all these represent small bits of knowledge that flow about the system. And so we're using this term internally to drive our agentic development, to think about how agents talk to external systems, talk to our database inside the AI platform called the vector database, and with the overall environment. This slide explains our different forms of the knowledge that we talk about. In fact, I was just having a conversation with our team yesterday. We're interviewing experts on how to do grant accounting and or accounting in the research area. And we're distinguishing between when we interview an expert or when we take a little bit of what the expert knows and we augment that with an LLM search that brings in additional content. So a lot of times when we prepare data that's going to get this vertical data that's going to get in the AI platform, we're obviously taking documents that represent knowledge from our experts, but we're also augmenting with LLM, oftentimes with database records. And so we have a different way of describing all these little knowledge bundles. We have knowledge bundles that we know we want a human to read. They're called human readable knowledge bundles. We have, or human understandable, we have ones that we know are going to be formatted specifically for the LLM and not to be read by a human. And so we're doing all sorts of interesting tricks in the agentic framework to think very differently about all these different bits of knowledge and knowledge fragments. This is our TritonGPT platform. It looks very simple. It looks like many others that you'll see out there. There's a series of assistants or GPTs that we have created Users can create their own assistants. They can share them. They can share their chats. We have the ability to begin to enter a question. You'll see down here at the bottom, we're using our Llama 3.3 model right now. We're experimenting with Scout, the Llama Scout model. We have a couple other models, but that's our big model. We actually do have the ability to access OpenAI's models. But this is the interface, straightforward. This is actually coming from an open source tool called Danswer, D-A-N-S-W-E-R. There's a company, actually a small company, it's actually two students who worked at the university who graduated a few years ago, and they created a startup that now offers this platform to anybody. And we've taken great advantage of it. So we don't have to worry about the UI programming and some of the innards of the technology. We focus on our very specific application development. This here is what our architecture looks like under the hood. We have up here on the top this thing called Danswer or Onyx. It's our interaction component, our dialogue engine. Our users here come in, they go through an authentication. There's a bit of a load balancer that routes them into the dialogue engine. And there we've got three main services: a service to handle the user interaction, an API service that talks to our vector database along with other data stores that we have on the bottom. And then we have our agentic service. This is where we put all our agents. It's essentially LangChain with Python code, but it can be anything. But right now we're working largely in LangChain and Python code. And we have a number of agents that we're creating, and these are agents that participate in solving a particular problem. The agents talk to tools. Tools have the responsibility of talking to an external system. So in one case, we have the ability to talk to our activity hubs, our data warehouse. This is our structured relational data that covers data in accounting, student data, employee data, facilities data, research data, all sorts of data. We now have an agent that's able to talk to that data and query out from it via a tool. We have some what we call execution software, the ability for the TritonGPT platform to interrogate a workflow tool. In this case, Quality Build is one of our popular workflow tools. And we're starting to work on getting data out of our content management system. We're already doing Bing search, so we have internet search built in. We have a tool for connecting to that. All of this ends up talking to a gateway that talks to our LLM. Llama 3.3 is our workhorse. It's the one we use the most, but we do have Llama Scout. We do have DeepSeek R1. We can get access to Gemini and Claude, and we now are getting some access to GPT 4.0. But 99% of everything is Llama 3.3. And we do that deliberately to keep our price way down. Two things have happened in the last couple months. One, Anthropic announced a protocol called Model Context Protocol. It's a standard approach for AI systems to talk to other systems, not AI systems, but other systems like a learning management system, a database, you name it. And we view the Model Context Protocol as this boundary around our whole agentic platform that will be a common way to talk to all the external systems I had just referenced. And then the second one is Google's agent-to-agent protocol. And we view that as a way for our agent framework to talk to another agent framework. So for example, if we were to collaborate with somebody in another part of the world or in another part of the country, and they have an agent that perhaps doing real good teaching of geometry. Rather than try to replicate that, we can just simply start to interact with that agent via the agent-to-agent protocol from Google. We think these two things, the agent-to-agent protocol and the Anthropic context model context protocol, will greatly expand collaborative AI between organizations and between industry. We think this is going to be a big deal coming down the road here a bit. And as you saw on the other slides, we have our models here. We actually have a safety system that we've crafted on top of this to check to make sure this environment is safe. I'll show you that in a little bit. While we can do fine-tuning, we haven't had the need to do fine-tuning yet. So we haven't done any fine-tuning, but it is in the architecture in case we want to do it. If we want to take a model, fine-tune it, and then redeploy it for a specific purpose. I don't think we're going to do much fine-tuning in the near future, and the reason is the agentic framework and the current retrieval augmented generation approach seems to be working very, very well for us. I'm going to talk very briefly here about regulation because I really want to get into our use cases now, but there's a very important need to look at this AI platform from a control, or what we call homeostasis. Just as the body tries to maintain the body temperature within a very narrow band, we want to have our AI platform maintain a very good level of quality and safety. But there's different levels. Starting at the top, there's societal norms. One country may have a different view of how the AI should work than another. Even in the United States, we have different views on how that should go. We have both federal at the country level and in our state law that prescribes what we have to do. So we have to have policy and control over the system that matches those laws. Inside our university, we have organizational policy, procedures, and processes that we have to enforce. Underneath that, we have AI safety monitoring, which I'll talk about a bit. And then I think when you get to this technical layer of agents, tools, connectors, and source data, you have to have technical controls there to ensure this system is safe and data isn't getting hacked or things aren't running awry. One thing we are learning, though, is there's two approaches to think about that regulation. The first one is crisp logic. This is that reasoning I talked about earlier, in which you're using real strict rules on how the quality of the system or the safety of the system will work. That's commonly done in most software development that's not AI generated. So it's common all the time. If this user, if user comes into a system and they're not a valid user, they don't get access to the data. There's nothing ambiguous about it. But with AI, we can use LLMs to also check quality. Now, this is a probabilistic approach for which there will be certain error rates. I think to handle regulation in AI platform, we have to get comfortable with both the crisp logic control and the probabilistic approach at the same time. Our Ensemble of Experts safety program uses four models: GPT-4o, which is out in the cloud. It uses Llama 3.3, it uses R1, and it uses Llama Guard. And what we do is every night we go through everything that's gone through the AI system, and we use a rubric that's looking at information hazards, malicious uses, discrimination, exclusion, toxicity, offensive statements, bias, misinformation, harmful interaction, criminal planning, etc. These are rubrics that are out there in the research community for evaluating the quality and safety of AI content. We use that rubric with those models to have each one of them score the content that's going in and out of our system after the fact for safety checks. When we find something that's not safe, we flag it, and then there's a manual process to uncover what's going on, either remove the content or remind the user, please be nice to your AI. So that's in place, and so far it's been going well. We think in time we will add inline safety checking. And in fact, Llama Guard, an open tool, has that ability. We can put Llama Guard right in front of Llama Scout, and it will add another safety check from the Meta Llama model. The Llama 3.3 model has a lot of guardrails built in, so we haven't had the need to use Llama Guard on top of it. But Llama Scout has less guardrails built in, so we think we're going to need some inline safety checking down the road. Okay, let's go get into how we're doing this. We've got a process inside the university where anyone can submit an idea. We have a group that reviews those ideas coming in. And then we've got, between my unit and one other unit, a way of analyzing and prioritizing those requests. And then we begin a proof of concept or the project proper. This is handling our student support cases and our administrative cases. For our teaching and learning use cases, we work directly with the researcher in their classroom. and they have more freedom to pursue how they want the AI to work in their classroom. And we're doing that deliberately because we're getting a number of interesting pilots from our faculty on how to improve teaching and tutoring using AI, including our TritonGPT platform. This is a simple example of the intake form we use. It's very simple. Somebody can submit and say, hey, I think it'd be a great idea to have an AI tool that does X. They give it a very simple score of what the impact might be, and what the solution could look like. That gets processed by our internal team. It gets turned into a little charter that describes the project, what we want to do with it. It describes some of the benefits, and then it goes to our committee to prioritize the work. And that's how we've gotten many of our assistants out. We have a work group that has 20 representatives from across the university, and we've got 2 leaders of it who then go through all of those requests and start to prioritize, and then that guides our activity in creating those assistants. Right now we have a number of assistants out on the administrative side. I'll talk a little bit about some of the teaching and learning ones. We have a UC San Diego assistant, which has pulled in thousands of web pages and documents within our vector database. And it's really good at answering questions about the university, like where can I eat on campus? What's the policy for taking holiday or vacation? What's the university's sick policy? If I'm going to enter an accounting transaction, how do I do it? We have a job description helper one, which is really geared for helping people write up job descriptions that we post when we hire people. And that is taken into 1,300 job description templates. And so we simply ask the user, what job description you're looking for. They don't have to say it exactly, but they can type it in approximately. We fetch what it is. They confirm it. We then ask, give us a couple sentences about it. And then it merges that in with the job description template. And it also lets the user do things like interview questions and marketing materials right from that same session. We have a general AI assistant, which is just opens up Llama 3.3 and nothing else, none of our institutional content. It's a way for the user to talk to Llama without any knowledge of the UC San Diego content to get things out of the model proper that might not be easily reached. It also includes internet search, which our UC San Diego assistant does as well. Our fund manager coach is really tailored around accounting, around research and grants, which is very complicated. And that is out in the hands of our 400 or so fund managers out there. We've curated or collected a lot of documentation on how to do grant accounting. It's either quite intricate, and all of that has found its way in the vector database. We've just launched a contract reviewer in which members, right now it's focused on our contracts and grants for research's office, where they get a lot of non-disclosure agreements that we have to sign. They simply email the document to TritonGPT, and email box TritonGPT picks it up, and it highlights and spits out a highlighted version of the contract. And then finally, the access to our database, we're going to start to release it in sort of early experience mode here in the next couple weeks. That's been in development for a while, and what that is doing is it's converting natural language to SQL code that can then get data from our data warehouse. And we're focusing it right now on our fund manager coach. If you're seeing a theme here, we're keeping all of our assistants very focused on very specific knowledge tasks. And on the academic side, so are our teachers. This is our pipeline of work. We have things in use. We have an instructional AI tutor that one of our faculty has created that helps tutor students in math classes and some geometry classes. It also plugs into our learning management system, Canvas. And then we've got a couple of other pilots going on in other parts of the university. We have a couple of faculty who just use our TritonGPT platform in their classroom. And so we're starting to see some growth on the teaching side as well. We have a number of things at the what I call components or the technology layer we're doing. But we're right in the middle of working on an image analyzer assistant. This is where actually Llama Scout can help with that. It can do good OCR, optical character recognition. And then we're also working on a dining assistant to help students find good dining, but more importantly, ask, hey, for this meal I'm eating on campus, what are the calories in it? What are the macronutrient content in it? What are the micronutrient content in it? And all that data is available. We're working on that assistant as well. We're out working on a one-stop shop for our students to get information on all the different services. That's going to be coming this summer. So we got a number of things that are in the pipeline that are going to find their way in over the next weeks and months. I'm going to go right to we got the Fund Manager Coach, which is sort of interesting because here are the questions that our users are asking in our Fund Manager Coach. How do I bill? How do I get a reimbursement? How do I update a project manager for the award? How do I submit an amendment for my contract? How do I create an invoice in the receivables software? How do I apply for a no-cost extension? All those questions get answered by this, and the answers come out kind of looking like this. But what we're also now doing is we're saying, hey, can we get data about my grant and break it out for me? And so here's an example of a natural language query that says, hey, develop a visual that shows the decrease in my balance on my grant over time. And this is a chart that's being generated by fetching data from the system and kind of doing a straight line prediction. Or another chart that would show a pie chart of what are you spending your money on your grant. All of these are now starting to come out of our data warehouse. Our contract viewer is kind of interesting too, because here the person in the Contracts and Grants office merely emails the contract in. It goes into a queue. Our TritonGPT in batch mode goes through it, and then it will then produce a finished document, which looks like this, in which we have redlined the document and put in the right language that we want in our contracts. Now you're going to see an interesting version of I won't say a crisp logic system, but we have a number of rules that we've come up with for evaluating the contract and how we want our language inserted. And so you see a number of rules here. Rule number 199, rule number 193, and yes, we've had a couple hundred rules identified. Rule number 140. This didn't take long to do, a few weeks, probably about a month and a half of work. And it's been saving our people in redlining non-disclosure agreements about 75% of their time. It's taken away. They now can just merely review it, make sure everything is good. We've carefully tried to control for hallucinations and error in this using the agentic tool set underneath. I'm going to leave with a couple thoughts here because I have a few more minutes. What we're discovering in our AI platform is we have to think about how to do this in a continuous delivery fashion. The AI isn't static. As we get new models in, things change a bit. We will often tweak and improve things on a daily basis. We'll have a new assistant coming out. Well, we'll launch it to, let's say, starting with 10 users, but then grow it to 50, then to 200, and then to 1,000. So it's more like a continuous delivery where we're just increasing the audience size for each of the assistants or each of the improvements over time. We watch the quality as it comes back and the user feedback. If things going in the wrong direction, we can kind of reverse back and reduce the population that's getting access to the tool. We haven't had a need to reverse because we've been carefully controlling the quality on the release out. We are now collaborating with other universities here, largely in California, but one on the East Coast of the United States. San Diego State University is in a partnership with us on creating assistants to be used in an instructional setting and tutoring setting in classes. We're working with the California State. It's a larger university system that is across the state in their chancellor's office, their system office, on some piloting there. We're working with UC Berkeley on layering in TritonGPT in parts of what they do. Our Agricultural and Natural Resources Division. A&R is onboarding into our system. And we're also bringing in Farley Dickinson, a small university in the East Coast, who's just looking for a high quality environment that doesn't break their bank account, that's affordable. Here's an example of how we're doing it with Berkeley. Berkeley's got a website that invites people and students to come in and connect with a university. And they've got a little chat window on here. When that opens up, that is TritonGPT under the hood. Berkeley has brought in their own content into their version of the vector database. It's really not a lot of work on our part to support. And we're finding the institutions we partner with, once we open up the vector database and the platform and they can start to ingest their content, it's not a lot of work on either of our parts to do some useful things. I'm going to stop here and talk about some maybe far out future things, but things we're thinking about. Right now, we can't trace all this content through the system. When the AI platform comes out with an answer and you see the sentence in front of you, it's not clear exactly where it came from. While there's references that you can see in the document and the references in the AI platform, it's sometimes hard to trace it through. Would it be possible in the future to trace all of the content, all the intellectual value of the content, individual words or phrases through the entire system? Meta produced a paper a little while ago called Large Concept Models, which take the AI approach from instead of the token, which is kind of a portion of a word, into a larger bundle that's a concept. It's actually a language element. That might be a way to do it. But I'll give you an example of what I'm talking about here. There's a researcher in the Netherlands, Luc van Loon, who is measuring how athletes are able to use protein to improve muscle. And what they're doing here is they're injecting a cow with isotope amino acid tracers. These are molecules that can attach to things in the cow that when they get milk out of the cow, those are now attached to the protein molecules. They then have the athlete drink that milk, and then they can follow where that protein ends up in the athlete's muscle. So they're able to trace the entire molecule through two species, the cow and then the human. Maybe someday we'll be able to do that with AI. If so, boy, that's going to open up a lot of interesting possibility, especially around intellectual property control and hallucination tracing. We are already starting to think about how we can use TritonGPT to automate TritonGPT. So how can we have TritonGPT do things for us? So for example, in our enterprise data agent, if we uncover a user who asks a question, a SQL fragment is generated and it is successful, we can store and we save that SQL fragment. There's no reason to generate a new SQL statement de novo from new if there was a prior SQL statement that was created. We can merely retrieve the similar question, retrieve the query, and rerun it. And so we're using those techniques in order to not have to go back to the LLM to recreate everything from scratch every time we want an answer from the user. You can call it caching. We're also using the thumbs up and the thumb downs rating on answers from our user community in order to prioritize certain answers. Hey, this is a good answer you gave, so prioritize it. That's a form of using reinforcement learning from the community to kind of improve how the AI is performing. Wherever my technicians are using their fingertips to type and create things, we're always asking the question, can you use AI to do that? We always want to keep a human in the loop, but we're starting to think more deeply about how we can use AI to actually automate the evolution of itself over time. I think this is going to create all sorts of interesting collaborations possible, where a research group might say, hey, we've got this great agent for teaching matrix math and matrix rotation and matrix manipulation, matrix calculus. And that could be a very specific tutoring agent. rather than us either trying to copy it and run it in our environment, we can just do agent-to-agent communication and find a way to interoperate across our institutions. So I think with the limits of AI upon us, the ability now to do agentic development and grow very focused solutions, kind of a garden of them, and then be able to collaborate with each other by either sharing the code, but probably more importantly, just open the API to the agent using the agent-to-agent standard from Google. I think all these things are going to create a really interesting future around AI collaboration. Now, are we going to have a version of Skynet from the Terminator here? I don't know. I was just reading this week of scientists who are growing neural networks using human neurons. And this is going to get kind of interesting over the coming years. Right now, I'm very happy to stick with silicon-based neurons. I'm not eager for a true wetware version of a neuron. And with that, I'm going to pause. But I want to end by just saying, with our TritonGPT platform, we've been able to bring our costs to roughly internally to about $2 per user per month, total cost of everything, US dollars. And that's well below the $20 to $30 per month that OpenAI is charging us. While some places put a UI in front of tokens and then get very low costs just doing tokens back and forth, that's because their usage is very low. I can have an infinite number of tokens. My price won't increase one bit. So I've got a very low price point. I'm more impressed with how well a very small team of 3 or 4 or 5 people have been able to create a lot of interesting agents and a lot of interesting tools. I do think we're going to step into this voice activation world where rather than even typing to the AI, we're talking to it and it is doing things for us. So all our thoughts on how do we do this for the learner, the student, the instructor, the administrator, the staff. And thank you for the time. Hopefully this was at least interesting, and I can certainly take questions if that's feasible.
Thank you very much. Thank you. Questions?
First, thank you very much for this presentation. A lot of very interesting ideas. Do you have examples from teaching and learning, like how professors use it in classroom or after classroom?
Yeah, we are seeing in the area of tutoring that an AI tutor can relieve the instructor of the tutoring and the teaching assistant of the tutoring. So the students become much more self-sufficient with the tutoring agent directly. And so we've seen a decrease in the amount of time in a specific subject. Now, the problem is the tutoring has to be very tailored around the content in the course. So you have to really focus it on course content. We've also found that in the Canvas plugin use case, there the instructor is using the tutor to evaluate test scores, test answers, but also help the faculty generate test questions as well. And so it's helping the faculty save time, the teacher save time. So we're seeing both of those. We have another faculty who's created another tutoring in nano engineering, very specific subject matter. And he's created a bot that's very focused on a couple of textbooks. So it's really the narrowing of the use case. We've had to do a bit of work for a tutor in geometry to help students master geometry. Geometry is very rules-oriented. So the faculty member there had to work very carefully with a graph database to really improve the quality of the answers coming out for the geometry tutor. Rules of geometry have been around for 2,000 plus years. They're not changing. But occasionally the LLM will hallucinate. So there's been a lot of work to try to get that, and I think they're pretty far along in that particular tutor. We have a general use case where a faculty member created an avatar of themselves using AI, and he's using his avatar as a tutor in his class. So it's an image of him speaking that he's having students use as kind of instructional material. So some clever use cases there. I think we're still in this experimental stage for the next few years as we grow those use cases. I can't say we have hundreds of faculty doing this. We probably have a dozen or two, but they're the leaders and they're out there. Some of them have some grant money that they've got, research money to support that. So those are some of the use cases we have out there.